What's up, Algebra 1? We're continuing our conversation about arithmetic sequences. What are arithmetic sequences? Arithmetic sequences are sequences that seem to be adding the same number over and over and over, or subtracting the same number over and over and over, and has more of a linear feel to it. So we're thinking about A for adding, or maybe even possibly subtracting. Okay, so for example, 1, 3, 5, 7. This is an arithmetic sequence because I seem to be adding 2 to get the next number. Now, anytime it breaks that pattern, that means it's not arithmetic. But as long as those values do have what's called a common difference between them, that is called an arithmetic sequence. They could be decreasing. If they're subtracting by 2 or by 3, if they're subtracting the same number over and over, that's also called arithmetic. So let's look and see 1 through 6, determine whether each sequence is an arithmetic sequence. If yes, identify the common difference. So the common difference can be calculated by doing the second number minus the first number. For example, if I look at number 1 and I think, well, the second number is 7 and the first number is 4, that means I must have added 3 the first time. But if you notice that second time, 7 to 9, it's only adding 2. And then it seems to add 3 again. So this is inconsistent. There is not a common difference. And so I would say this one is no. This one's not arithmetic. It does not follow that pattern of being linear or being arithmetic. So for this one, 13 minus 15 is negative 2. And now I need to examine, is this continuing to subtract 2 throughout the whole sequence? 15 minus 2 is 13. 13 minus 1 is 11. 11 minus 2 is 9. So the answer to this is yes. And the common difference is negative 2 because I'm going down. I am decreasing. So the sign of the common difference controls or means that it's either adding if it's positive, or if D is a negative value, that means you're really subtracting. So let's try another one. Let's see. 10 minus 7, it looks like it's adding 3, adding 3, adding 3. So the common difference is positive 3, and this one is yes. Let's think about this one. If I did negative 5 minus negative 6, negative 5 minus negative 6 is positive 1. I was going to pull up my calculator, but it seems like I don't have a calculator pulled up right now. But the problem is that right here it's adding 2, and again it adds 2. So I think this one is going to be no, because they don't seem to be consistent in that common difference between the values. So I want you to try 5 and 6 on your own. Write yes or no, and if you write yes, tell me what that common difference is. So the next section says find the next 3 terms of each sequence. So these are assumed to be arithmetic, and so I need to find out what that common difference is. So the very first one, I'm going to take that second number and subtract the first number, and it looks like I'm adding 4 every time. So 15 plus 4 makes 19. 19 plus 4 makes 23. And 23 plus 4 makes 27. So let's now look at one that is more decreasing over time. Again, the second number minus the first number. So I look and see that this is actually going down by 2, and that's why my common difference is negative. So 16 minus 2 is 14. 14 minus 2 is 12. And 12 minus 2 is 10. All right, so you try 9 and 10. Try to tell me what the next 3 terms are and make sure you find the common difference. Let's see what happens. Supposed to be moving forward. All right, so we're going to be using that equation that we've been working on in class, a sub 1 plus the common difference distributed into n minus 1. And then it says find a sub 24, and that really means what is the 24th term in the sequence. So let's go for it. A sub 1 is the first number in the sequence, which happens to be 1. And the common difference, if you subtract the second number and the first number, 3 minus 1, it looks like I'm adding 2 to get the next number in the sequence. So I'm going to start replacing values in the formula. A sub 1 is 1, plus the common difference of 2 distributed in the n minus 1. So I want to drop the 1, multiply 2 into n, multiply 2 into negative 1. And now I have some like terms that I need to calculate. 1 minus 2 is negative 1. So now I have a formula that will generate my sequence. For example, if I was to do 2 times 1 minus 1, you get the first number, which is 1. Or the second number is 3, 2 times 2 is 4, minus 1 is 3. So now we want to calculate the 24th term. So if I want a sub 24, let's do 2 multiply 24 minus 1. 2 times 24 is 48, minus 1, 47. We'll do one more. Let's try one that is decreasing. Number 12. This one has a common difference of negative 3, because I got negative 1 minus 3 giving me negative 4, and my first value here is negative 1. So negative 1 plus the common difference of negative 3. And if I'm adding a negative 3, I might as well just put minus 3. So this doesn't always have to be a plus. It could be a minus if the common difference is negative. And then I'm distributing into n minus 1. So let's distribute. Negative 3 times n, negative 3n. Negative 3 times negative 1, positive 3. And again, I want to combine like terms. Negative 3n doesn't have any like terms, but negative 1 plus 3 is positive 2. And so now that I have my formula that will generate the sequence, I want to plug in 24, because I want the 24th number in the sequence. Now, negative 1, negative 4, negative 7, I should get a number that's deeper in the negatives. And so let's see, negative 3 multiply 24 plus 2. So negative 3 times 24, that's negative 72. And if you add 2 to that, you get negative 70. Okay. So I want you to try 13 and 14 on your own. And then I'll set up your word problems for you. Write a formula to represent this sequence. Charlie just deposited 115 in his savings account, and then he deposits 35 into the account every week. So it sounds like it's increasing. So it sounds like the first number was 115. If you add 35 to that, you get 150. If you add 35 to that, you get 185, and that process just continues. So let's start our formula. The first number is 115. You're adding 35 each time. And so now you just need to simplify and tell me what is your formula. Now it says after 30 weeks, how much total money has he deposited? So we need to kind of figure out, well, if n is the value of 30, plug in 30 into your equation and see how much money you have after 30 weeks. Now the next one is very similar, and this is our last problem. There's a manager of a soccer team, and she's handing out cups of water at practice, and each cup of water is 4 ounces. Now a cup is actually 8 ounces, but some cups are smaller, so this must be a smaller cup than an actual cup, and it only has 4 ounces that it holds. So she begins practice with a 128-ounce cooler. So if you think about it, her cooler is full to begin with. But then as she pours out water in her cup, this decreases. The water then goes down a little bit until it is empty. Can I give you a visual? So this one is subtracting 4. Every time she pours water in the cup, we are subtracting 4 from 128. So 128 minus 4 is 124, minus 4 is 120. So this is the sequence we're trying to discuss. So let's start out with the fact that it's 128. I'm subtracting 4 each time she pours into the cup. So let's see, can you simplify the problem? That's your turn. You try to finish that. And then it says, well, how much water is in the jug if 14 cups are used? So then plug in 14 into your sequence and see what you get out. Thank you so much for watching this video. Good luck and have a good night.